Hello students, welcome to Physics CET SANKALP classes. So I hope you are doing good, right? So today we are going to start a new chapter, Semiconductor Electronics. It's related to electronics and it is quite interesting chapter, right? And it is also very important for engineering level. So if you select any telecommunications or electricals, electronics, so related branches, this chapter is very important. So before we go with the multiple choice questions, first we'll discuss with the synopsis related to that. Semiconductors. So what do you mean by semiconductor? So semiconductor or the material. So semiconductor or the material having electrical conductivity smaller than that of the conductors, but higher than that of the insulators. Okay. So according to the band theory of solids, semiconductors are materials which have small energy gap between the valence band and the conduction band. The energy gap is about 1 electron volt. We have two types of semiconductor. One is intrinsic semiconductor and extrinsic semiconductor. What is intrinsic? So they are chemically pure and possess low conductivity. So they are, you can say it is pure and they possess low conductivity. So as you know that at absolute temperature, it behaves as an insulator. It behaves as an insulator. As its conductivity increases, as temperature increases. So if the temperature is increased, the conductivity increases. At all temperature, the number of electrons and number of holes are equal. That is, Ne is equal to Nh, that is equal to Ni. That is very important. So what is eccentric semiconductor? It is prepared by doping an intrinsic semiconductor with suitable impurity atoms. Okay, here the conductivity is high and it increases with increase in impurity concentration. Okay, so as you know that the dope, depending on the doping agents used, so we are going to classify it into two types. One is the N type and other one is the P type. What is N type? So N type, we can say number of electrons will be more than number of holes. Okay, so here the doping N-type semiconductor is made by doping silicon or germanium. So when you take a material like silicon and germanium with pentavalent impurities, so with pentavalent impurities like porous, arsenic, okay. So all this impurities, using that you are going to make the N-type semiconductor. Okay, next is P-type semiconductor. So here the electrons are major charge carriers, where in N-type, in P-type, holes are majority charge carriers. So here you can say NH is much greater than Ne. So here the doping element will be trivalent impurities like boron, aluminum. Okay, all these components we are going to use it. Okay, right. So the intrinsic carrier concentration of eccentric is given as Ni. Ni is equal to root of Ne NH. Ne and NH. Okay. A hole is a vacancy of electron in in a bond, and it can drift in an opposite direction, that of electron. Okay, these are the key points related to semiconductors. So you have to go through with all this. Okay, I'll finish with PN junction. Then later we can copy down with all this highlighted points. Okay, next, PN junction. It is a device with one side P-type and the other side N-type. It is also known as semiconductor diode or junction diode. As you know that when you are going to say a diode is being forward bias or reverse bias, if the P terminal of a diode is, if the P terminal of the diode is connected to positive terminal of the battery and negative terminal of the battery is connected to N type, then we are going to say it is forward bias. The vice versa of that is going to be reverse bias. The depletion region is a thin region on either side of the junction where there are no majority charge carriers. The potential difference developed across the junction is called junction potential difference. So it is nearly 0.3 volt for germanium crystal. So 0.7 volt for silicon crystal. Okay. So this one I told the PN junction is said to be forward bias and P type is positive potential and N type is negative potential. Now it conducts large current and resistance offered by the junction is small in the case of forward bias. This is important, you have to remember that. So in the case of reverse bias, the junction does not conduct and it offers large resistance. Okay, so you can say PN junction conducts only in one direction. Okay, so that's why it is used for a rectification. So the application of diode is half rectifier, half wave rectifier and full wave rectifier. Okay, so other special purpose diodes like Zener diode, light emitting diode and solar cells you would have studied. Okay, just you have to recollect all this. Okay, so now just you can make a note of whatever the points I have highlighted. Okay, so that will be important for you while solving the multiple choice question. So after you write that, I'll give some time. We'll start with the transistor. ಸೊ ನೀಟಾಗಿ ಲೈಕ್ ಏನಿದೆ ಆ ಹೈಲೈಟೆಡ್ ಪಾಯಿಂಟ್ಸ್ ಏನಿದೆ, ಯು ಮೇಕ್ ಎ ನೋಟ್ ಆಫ್ ದಟ್. Okay, so the thing, I think half wave, full wave would have studied, right? So in the half wave we'll be having only one diode. So we are going to discuss about the two cycles. One is the positive cycle, the other one is negative cycle. Okay, so the same way in the full wave also, I hope you are clear. So go through with that all the concepts. Okay, so differences between p type and n type. Okay, so that is also very, very important. Okay. A special purpose diodes ಯಾವುದು like xenon diode, photodiode, light emitting diode, solar cell, ಅದು applications uses applications ಗಳು ನೋಡ್ಕೊಳ್ಳಿ. ಓಕೆ, ಸೊ xenon diode ಏನಕ್ಕೆ ಯೂಸ್ ಮಾಡ್ತೀವಿ ಅನ್ನೋದು, it is also used as an voltage regulator. Okay, it is used as an voltage regulator. Okay, the next is transistor. So what do you mean by transistor? So transistor is a device, right? So it is a device with three doped regions forming two p-n junctions between them. Okay, so types of transistor you have NPN transistor, PNP transistor, NPN transistor and PNP transistor. So this is how the symbol, where the arrow, if it is coming out, then it is NPN. If the arrow is going inside, it is PNP. Okay, the middle region is the base. The other two regions on both the sides are emitter, collector and base. So wherever you see the arrow mark, okay, there you are going to say it is an emitter. So this is emitter, base, collector. So emitter, base, collector. Okay, and emitter, base, collector currents, so IE is equal to IB plus C. For transistor, there will be this, because you are not going to study in theory. Okay, that, but you have to remember all these formulas, whatever I am highlighting. Okay, ಬೇಗ ಟ್ರಾನ್ಸಿಸ್ಟರ್ದಲ್ಲಿರೋದು ಹೈಲೈಟ್ ಮಾಡಿರೋದು ಬರ್ಕೊಳ್ಳಿ. That is the synopsis for transistors. So transistors is not there for PU level, but for the competitive level, these are very, very important. I hope you are clear. Right. Next, a transistor can act as a switch. The basic function of transistor is amplification. So it is used in amplifiers use ಮಾಡ್ತೀವಿ transistors to boost up the signals. Okay. The voltage gain of the amplifier is the ratio of the output voltage to the input voltage. So you have to please remember this formula also. So voltage gain, current gain, voltage gain anta ಕರಿತೀವಿ ಇದನ್ನ. AV is equal to delta V out divided by delta V in. Delta V out divided by delta V in. Okay. So along with that, you have to remember with one more formula also. Relation. So relation between alpha, beta and gamma, alpha and beta. So ಅದರಲ್ಲಿ ಬರಿತೀನಿ. So beta is equal to alpha divided by 1 minus alpha. Okay, so you have to remember this formula also. You have to please make a note of that. Next, logic gates. What is logic gate? It is a digital circuit which follows certain relationship between the input and output voltages. We have basically three basic gates: NOT gate, OR gate and AND gate. NOR and NAND gate are the universal gate. Since you can, using these gates, you can define all the basic gates na define ಮಾಡಬಹುದು. That is the only intention. Okay. Now you can see the symbols here for NOT gate. This is a circuit symbol. Whenever you give the input 1, output you are going to get 0. So ಇದನ್ನ ಏನಂತ ಬರಿಬಹುದು? ಇಲ್ಲಿ A ಕೊಟ್ಟಿದ್ರೆ ಇಲ್ಲಿ Y is equal to A bar ಆಗುತ್ತೆ. Okay. OR gate. OR gate. So that is a circuit symbol. So if both are 0, output also 0. In all other cases it is 1 1 1. So digital, when we talk about the digital, you will be having only zeros and ones. Okay, so zeros and ones ಇರೋದ್ರಿಂದ ಅದೇ ಫಾರ್ಮ್ಯಾಟ್ ಅಲ್ಲಿ ಬರೀತೇವೆ. ನೆಕ್ಸ್ಟ್ AND gate. So this is circuit symbol. ಇಲ್ಲಿ OR gate ಅಲ್ಲಿ ನೋಡಿ y is equal to a plus b. ಇಲ್ಲಿ y is equal to a into b. Okay, so ಇಲ್ಲಿ ನೋಡಿ, if both are high, then the output will be high. Remaining it is 0. NOR gate. So y is equal to a plus b the whole bar. So whenever there is both the inputs are 0, output will be 1. Next, NAND gate. So y is equal to a dot b the whole bar. So here if both are 1, then the output will be 0. In all other cases, it will be high. Okay, make it fast. Write this part. Logic gates, part number 8. So write the truth table symbol, and it is also important for your PU level also. This logic gates. ಟ್ರೂತ್ ಟೇಬಲ್ ಬರ್ಕೊಳ್ಳಿ. ಸರ್ಕ್ಯೂಟ್ ಸಿಂಬಲು ಟ್ರೂತ್ ಟೇಬಲು ಆ ಎಕ್ಸ್ಪ್ರೆಷನ್ಸ್ ನಾನೇ ಬರ್ಸಿದ್ದೀನಿ ನೋಡಿ, ಅದೆಲ್ಲ ಬರ್ಕೊಳ್ಳಿ. ನೀಟಾಗಿ ಬರ್ಕೊಳ್ಳಿ, ಅದನ್ನ ಬರ್ಕೊಂಡ್ರ. ಸೊ ಈ ಟೇಬಲ್ನ ವಿಲ್ ಬಿ ಕಾಲಿಂಗ್ ಇಟ್ ಆಸ್ ಅನ್ ಟ್ರೂತ್ ಟೇಬಲ್. I hope you are done with that. Okay. Next. A PN junction diode works as an insulator. PN junction diode works as an insulator if it is connected. If it is connected. If it is connected to reverse bias. If it is connected to reverse bias, then you can say it works as an insulator. Next, a transistor is connected in common emitter configuration. The collector supply is 8 volt and the voltage drop across a resistor of 800 ohm in the collector circuit is 0.5 volt. If the current gain factor alpha is 0.96, then the current, okay, you have the formula that IB, current across the base, is equal to IC divided by IB. This is nothing but beta. Beta, or also you can write this as alpha divided by 1 minus alpha. So it is 0.96 divided by 1 minus 0.96. You will get it as 24. Beta is equal to 24. So next I have told you to find IB is equal to IC divided by 24. So I can be written as V by R into 24. V is 0.5 divided by R is 800 into 24. So when they solve this, we'll get it as 26 microampere. I hope you are clear with that. Next. So ಇದರಲ್ಲಿ ಹೇಗೆ ಅಂದ್ರೆ ನೆಕ್ಸ್ಟ್ ಪ್ರಾಬ್ಲಮ್ ಆಯ್ತು ಅನ್ಸುತ್ತೆ. ಇಲ್ಲೇನಂದ್ರೆ ಥಿಯರಿ ಬೇಸ್ಡ್ ಸ್ವಲ್ಪ ಜಾಸ್ತಿ ಇರುತ್ತೆ. ನ್ಯೂಮರಿಕಲ್ಸ್ ವಿಲ್ ಬಿ ಲಿಟಲ್ ಬಿಟ್ ಲೆಸ್. Okay. In an n-type silicon, which of the following statement is true? So electrons are majority charge carriers, and n-type ಅಲ್ಲಿ electrons majority and trivalent, pentavalent. No. So first option is ruled out, second option is ruled out, fourth also it is ruled out. Okay, so option 3 ಅಲ್ಲಿ ಏನು ಹೇಳ್ತಾರೆ ನೋಡಿ, the holes are minority carriers and pentavalent atoms are doped, or the dopants ತರ ಯೂಸ್ ಆಗುತ್ತೆ. which of the statement is true for p-type semiconductors? p-type semiconductors, p-type ಗೆ ಮೆಜಾರಿಟಿ ಚಾರ್ಜ್ ಕ್ಯಾರಿಯರ್ಸ್ ಬಂದು ಹೋಲ್ಸ್, ಪೆಂಟಾ ರೂಲ್ಡ್ ಔಟ್, ಟ್ರೈವೆಲೆಂಟ್. ಸೊ ಇಲ್ಲಿ ಹೋಲ್ಸ್ ಆರ್ ಮೆಜಾರಿಟಿ ಚಾರ್ಜ್ ಕ್ಯಾರಿಯರ್ಸ್ ಪಿ ಟೈಪ್ ಅಲ್ಲಿ. ಸೊ ಆಪ್ಷನ್ ಡಿ. D or 4. Okay. Carbon, silicon, germanium have 4 valence electrons each. They are characterized by valence and conduction bands separated by energy band gap respectively equal to, e.g. energy gap in copper, silver and silicon and germanium. Which of the following statement is true? So it is directly, we can say carbon is greater than silicon, silicon is greater than germanium. So option 3. In a junction diode, the holes are due to missing of as you know that the electrons will be missing, holes is going to be created automatically. So shall we move to the next problem? In an unbiased PN junction, holes diffuse from P region to N region because hole concentration in P region is more as compared to N. When a forward bias is applied to a PN junction, when a forward bias is applied to an PN junction, when a forward bias is applied to a PN junction, it lowers the potential barrier. Next, the potential barrier in the depletion layer is due to ions. Avalanche breakdown is due to collision of minority charge carriers. At high reverse voltage, the minority charge carriers acquires very high velocities. These, by collision, break down the covalent bonds, generating more carriers. This mechanism is called avalanche breakdown. In a semiconductor, there are no free electrons at 0 Kelvin. So option 3. At 0 Kelvin, temperature behaves as an insulator. Xenon diode is used as AC voltage stabilizer. ಯಾಕಂದ್ರೆ constant voltage ಇರ್ಬೇಕಲ್ಲ. AC voltage stabilizer. For a transistor amplifier, the voltage gain is low at high and low frequency and constant at mid frequency and constant at mid frequency. So it is low. So option 3. The value of beta from transistor, for which, so you have the formula, beta is equal to alpha divided by 1 minus alpha. Alpha value substitute ಮಾಡಿ find out ಮಾಡಿ ಹೇಳಿ ನನಗೆ. So how much you got? So beta is equal to 19. Okay, when you solve that, you will get 19. In a semiconductor, the constant concentration of say, electron is 8 into 10 to the power 14 per centimeter cube. Okay. In a semiconductor, the concentration of electron is. So I can write concentration of electron is nothing but Ne anta bariboda. So Ne is 8 into 10 to the power 14. So NH is equal to 5 into 10 to the power 12. So when you see in both the cases, Ne is much greater than NH. So it is N type. Okay. When a semiconductor is heated, its resistance decreases. When a semiconductor is heated, its resistance is decreases. Next, the forbidden gap in the energy bands of the germanium at room temperature is about so forbidden energy gap ನೋಡಬೇಕು. That is as you know that Eg of germanium is 0.67 electron volt. So option 3. Okay, that you have to remember. To obtain p-type germanium semiconductor, it should be doped with trivalent. So option 3. Which impurity is doped in silicon to form N-type semiconductor? Arsenic. So option 3. In N-p-type semiconductor, germanium is doped with so option D, all of this. Next question. In eccentric semiconductors, the gap between conduction band and valence band is near about 1 electron volt. So option 3. Function of rectifier is to convert from AC to DC. Zener diode takes place if so as you know that Zener breakdown can occur in heavily doped diodes. In lightly doped diodes, the necessary voltage is higher and the Lagrange multiplication is then the chief process involved. So directly you can say that it is option D, doped impurity is high. Next, which one of the following is not a correct statement about semiconductors? Which one of the following is not a correct statement about semiconductors? So silicon is a direct band gap semiconductor. So in an N-type semiconductor, the Fermi level lies closer to the conduction band edge. Okay. The holes are the charge carriers in so it is 25th is option 4. Assuming the diodes to be of silicon with forward resistance 0, the current in the following circuit is. Assuming the diodes to be silicon with forward bias, forward resistance 0, then the current in the circuit is. So as you know that maximum in insulators and overlapping in metals. So maximum in insulators and overlapping in metals ಇರೋದ್ರಿಂದ assuming the diodes so one is forward bias, other one is reverse bias. So forward bias ಮಾತ್ರ conduct ಆಗುತ್ತೆ. So it is 10 milliampere. So it is 10 milliampere. Okay. So E they've given us 20, resistance 2. So 20 divided by 2 ಅಂದ್ರೆ 10. So milliel ಬರುತ್ತೆ. Okay, so you have like this, you know the formula. I is equal to E divided by R. So E is 20 divided by 2 into 10 to the power 3. So 10 into 10 to the power minus 3 is your I. When a solid with band gap has a donor level just below its empty energy band, the solid is a positive feedback from outside to input. A positive feedback from output to input in an amplifier provides oscillation of constant amplitude. So it is an insulator. Okay, when a solid, so in that cases, you can say the option 1 is the right answer. Next, to obtain P-type silicon semiconductor, we need to dope pure silicon with aluminum. So to obtain P-type silicon semiconductor, we need to dope pure silicon with aluminum. For transistor action, which of the following statements are correct? Base emitter and collector region should be similar size. The base region must be very thin and lightly doped. The emitter junction is forward biased and collector junction is reverse biased. Both the emitter junction as well as the collector junction are forward biased.